All right. We are going to work question number 4. First of all, we need to write our equation. We're going to have silver nitrate and aluminum chloride, see if I can talk, aluminum chloride, silver nitrate, plus aluminum chloride react with each other, the double replacement reaction. So the silver and aluminum will switch places. We'll get silver chloride and we'll have aluminum nitrate. Now we need to balance it. We've got 3 nitrates here, so we're going to need a 3 here. That now changes silver to 3, so we're going to need 3 silver chlorides, and that gives us 3 chlorines, which we had already. So we have our equation written. Now we read our given amounts are 4.22 grams of aluminum nitrate and 7.73 grams of aluminum chloride. Once again, it's a limiting reactant. We're solving for the mass of silver chloride. So we're going to start with the first one, silver nitrate. We have 4.22 grams of silver nitrate. Now we have to change that to moles. 169.87 grams in 1 mole. The ratio of silver nitrate to silver chloride is 3 to 3, 3 moles AgNO3, 3 moles of AgCl. And now we need to change back to grams because we've gone over the bridge. Silver chloride, AgCl, 143.32 grams per mole. All right. Next, we'll solve with 7.73 grams of aluminum chloride. All right, aluminum chloride molar mass, AlCl3, 133.34. All right, so now we're looking at aluminum chloride changing to silver chloride. Our ratio is 3 moles of silver chloride will be formed for every 1 mole of aluminum chloride. And then we have to change back to grams, 143.32 grams in 1 mole. Once again, you're going to find moles of silver chloride. The reactant that makes the lesser amount is the limiting reactant, and your answer for the maximum amount taken, or amount made, is going to be whatever the smaller amount is. Well, question 5, we're given the reaction this time. It tells us that we have 3.5 grams of each reagent. So that means we have 3.5 grams of lithium and 3.5 grams of nitrogen. We'll start with the lithium. 3.50 grams of lithium. The molar mass of lithium is 6.9 grams in 1 mole. The ratio is 6 moles of lithium, and we're solving, I guess I should have looked to see what we were solving for. We're solving for the theoretical yield of lithium nitride. So our ratio is 2 moles of lithium nitride for every 6 moles of lithium. Theoretical yield simply means, again, what is the maximum amount you will make, which means the smaller amount, because your maximum amount made by whatever is limiting. And now we're going to do lithium nitride. Lithium nitride, 34.83 grams in 1 mole. Okay. The next one, 3.5 grams of nitrogen. Molar mass of nitrogen is 14, but just like that oxygen earlier, there are 2 nitrogens in every molecule. So our molar mass is 28 grams per mole. Our ratio here is going to be 2 to 1, 2 moles of lithium nitride to 1 mole of nitrogen gas. And once again, we'll use lithium nitride's molar mass to calculate how much nitrogen that amount of nitrogen would make. Okay, the smaller one is what is the maximum amount you can make. Percent yield. Percent yield is when you take a given amount, when you take the amount from a chemical reaction, the results, the actual amount, divided by the theoretical times 100. All right. So, first we need to write our equation. We're going to react aluminum and oxygen. Aluminum plus oxygen gives us aluminum oxide. And we balance that like this. We've already balanced this one. Our given amount, we have 2.5 grams of aluminum and 2.5 grams of oxygen, and we're going to solve for the theoretical amount of aluminum oxide. Now notice, it says we produced 3.5 grams. That number is our actual amount. All right, we'll come back to that. 2.5 grams of aluminum divided by the molar mass of aluminum, 26.98 grams in 1 mole. Our ratio is 2 moles of aluminum oxide to 4 moles of aluminum. And I'm just going to go back to number 1 because I think that's where we used it before. No, it was number 3. And the molar mass of aluminum oxide was 101.96. All right. Now we'll do the same. 2.5 grams of oxygen. Molar mass is 32 grams in 1 mole. We have 3 moles of oxygen that react with every 2 moles of aluminum oxide that is formed. And again, 101.96 grams. You'll do the math. Whichever answer is smaller, you're going to take 3.5 grams divided by the smaller amount times 100 to get your percent yield. All right, we'll stop there.